Hi everybody, I'd like to welcome you to another short expert session dealing with time-dependent routing for today. Maybe you've already seen some of our samples where we are using the so-called speed patterns and truck speed patterns for the computation of more realistic driving times and driving distances in the context of routing. Regular routing, which for me just means from one location to another location. And this short session is just dealing with another topic, which is in fact the time-dependent routing, but applied in the context of so-called isochrone routing. So I just want to motivate you or show you that this mechanism of time dependency also works in a context that is used for proximity search, for example. So what you can see here on the screen right now is the area I can reach from a given center point within a given number of seconds, for example, 900 seconds. By the way, the isochrone calculation supports, let's say, a threshold of time or as an alternative of distance. Distance is not relevant for the moment because the distance is not so much, there's not such a big impact on the driving distance in the time dependency. Now, let's have a look at the results. 900 seconds means 15 minutes. So this is the area we can reach within 15 minutes around the corporate headquarters from PTV. And what I also have considered now is the time of the computation. It's on a Sunday, 9 p.m., 9 o'clock in the evening. And now with changing the timestamp of the snapshot, you can see that the area changes. So later in the night, I have covered a bigger area I can reach around midnight. And in the next morning, the area size decreases once again. Of course, we start to get into, let's say, some kind of 5 o'clock in the morning, 6 o'clock in the morning, some kind of rush hour. And of course, during rush hour, I cannot cover or cannot drive that far away from the center. So how do I achieve this? It's quite simple. We have the so-called speed patterns, feature layer called speed patterns, and you can just use an XML fragment like this one to consider this additional time-dependent data, which is based on 15 minutes time slices. So we get 96 different values for each day of the week, describing the, let's say, the percentage impact on the free flow speed. So that's what we consider here. And by applying these additional data, we can calculate these areas of reachability. So this works fine with regular A to B routing, as long as you do not want to consider break and rest rules, because you cannot combine what we call dynamic routing with break and rest rules at the same time. That's quite simple to explain. When we calculate a dynamic route, then we calculate it starting from the start point, and we flood the network of the streets into one direction, which is the destination. And then when we are done with the algorithm, we have the driving times, driving distances, and each driving time and driving distance is considering the moment in time when we reach that segment. So when we have calculated the polygon and the scheme of date and time and distance, we cannot apply the break and rest rules afterwards, because this would change the time context of each segment. Okay, I don't want to go into details within this video. I just wanted to show you that this is possible to consider the dynamic routing aspect in an area search, in an isochrone search as well. So you can also use this in search for nearest, which is our other method that is for the corridor search or proximity search around a given coordinate. That's it. That's what I wanted to show you. So thank you very much. If you have further questions, if you want to have further movies, just join my channel on YouTube and give me some feedback, or write to bernd.welter at ptvgroup.com, and then we will see what we can do for you. Thank you very much. Bye.